students, so here we have the question TiH2O6Cl3. This complex actually it is violet in color, but the question says when it is heated it becomes colorless. Give reason. Obviously this question is again from CFT, crystal field theory, and we need to use the crystal field theory concepts to solve this kind of questions. So before starting the question we need to understand what type of complex is this. Basically this complex is made up of this complex ion TiH2O6 3+, and it is one Ml6 type of complex, one central metal bonded to 6 ligands, hence it is octahedral. Now in the first place, why the complex is colored, why it is violet in color? This is the first thing. So here the central metal is Ti3+. What is the electronic configuration of Ti3+? We know titanium Ti, it is 22 atomic number, so argon 4s2 3d2. Therefore titanium 3+, it becomes argon 3d1. Here the central metal titanium, it has D1 configuration and it is bonded to H2O ligand, 6 H2O ligands. If we draw the splitting diagram, it looks like this is your energy axis. These are the 5 d orbitals of titanium 3+, and we have one electron over here. As it is octahedral field, therefore it will split into T2G and Eg. As there is only one electron in the d orbital, therefore the one electron will move into T2G. Therefore our electronic configuration becomes, this is T2G1 and Eg0. If we finish the diagram, it looks like this. Here is our delta O. This is our body center. This is minus 0.4 delta O. This is plus 0.6 delta O. This is a complete crystal field splitting diagram for the given complex. Now the first question initially was why the complex is colored, it is violet in color. Why so? Because in the aqueous solution we have this complex ion, the complex ion containing a central titanium 3+, that is having T2G1 Eg0, this electronic configuration. And we can simply observe there is some energy gap between this T2G and Eg. This energy gap, let's say this energy gap is delta E. This delta E can be written as h nu Planck's constant into frequency of a radiation, or we can simply say hc upon lambda, where c is the speed of light, lambda is the wavelength of the radiation. This is wavelength of the radiation. So what we can observe? We can observe there is a certain energy gap between T2G and Eg, and this energy gap can be given by delta E, which is equal to hc by lambda. Now the energy gap between this T2G and Eg, this is not significantly high. Therefore simply by using visible light we can supply sufficient amount of energy to this electron so that it can move to Eg. So when sufficient amount of energy is supplied into this particular electronic configuration, we are supplying some energy, it becomes T2G0 Eg1. This is called the ground state, This is called the excited state. Now, when this electron is moving from T2G to EG, it absorbs a radiation whose wavelength is in the visible region. So this compound, it absorbs visible light for this electronic transition. This is also called a d-d transition. Why d-d? Because T2G set of orbitals, they are made up of d. EG set of orbitals, they are also made up of d. As electron is moving from T2G to EG, hence the term d-d transition. So during this d-d transition, the complex is absorbing visible light. Hence we observe a color. To be precise, the complex, the solution, the aqueous solution of TiH2O whole 6,3 plus or whole 6Cl3, this absorbs yellow light from visible region. And as I already told you, whenever some compound is absorbing some light, it will show the complementary color. The complementary color of yellow is violet, hence it seems violet in color. Right? Now what happens when the complex is heated? When the complex is heated, the idea is very simple. When TiH2O whole 6 Cl3 is heated, the ligands no longer present with Ti3 plus. So obviously in absence of ligands, there will not be any crystal field splitting, there will not be formation of any T2G and EG orbitals, and there is no question of having a d-d transition. This is why the complex will be colorless now. Therefore what we can conclude, in absence of ligands, there will be no d-d transition. And the complex becomes colorless. So once again, finally, we jot down this thing. Whenever we have a complex given in its aqueous solution, a complex compound, and there occurs crystal field splitting, there is electronic transition from T2G to EG orbitals. And if the transition, during the transition, it absorbs visible light, then the complex is usually colored. Now on heating, if the ligands are removed, there is no longer crystal field splitting and there is no d-d transition. In absence of d-d transition, there will be no color of the complex. So this is all about the solution of this particular question. Thank you for watching.